Spinning top. This fascinating kid store that many of us have played with is now messing with our understanding of physics. It keeps spinning even when tilted, defying the laws of gravity. Or is it?
Let's take a look at the ideal situation. A perfectly symmetric top is rotating about its own axis. It is upright and therefore gravitational force acts in the same direction as the axis of rotation, which means that there is no effect of gravity on the actual spin. Since the object is spinning, there is a torque causing the angular acceleration and an angular momentum, which shows the amount of rotational motion of an object.
These two are vector quantities, and so they have their directions. Angular momentum basically shows the axis about which the object is spinning. For determining the direction of the torque, we can use our hand. Our fingers curling demonstrates the rotation and thumb demonstrates the direction of the torque. Fortunately, this isn't the case. Spinning tops are not perfectly symmetrical, and so gravity plays its role.
Let's say at point A, gravitational force is the strongest. Opposite of A is point B. As point A will be accelerated downwards, point B will be accelerated upwards. This in turn will result in another torque trying to rotate the top upside down. However, as the object is spinning about its own axes, points A and B will be changing their position. Thus, the torque from the gravity will lead to a tilt of angular momentum, an axis of rotation, and result in rotation of the upper top. This is precession. This is exactly what happens with the Earth due to the tidal force.
Anyway, back to the spinning tops. Sometimes this precession is barely visible, whereas other times the tilt of rotation is quite large. But what affects it? Well, let's add just a tiny bit of math, and here's the diagram.
Showing the size and direction of the angular momentum and the torque from gravity. As we see, there is much greater change of rotational axes when the initial angular momentum is smaller. Thus, as we are increasing angular velocity, and so the angular momentum is increased, precession decreases.
But why bother? Well, because there's another force acting on our spinning top, friction. If there wasn't friction, our spinning top would be spinning forever.
Due to the conservation of energy, spinning top loses its kinetic energy, which is converted into heat because of friction. As kinetic energy decreases, velocity of the spinning top does as well. Precession therefore increases and the spinning top falls.